Hi, folks. My name is Sammy Sigmund. I'm the Chemical Hygiene Officer in the Chemistry Department here at Appalachian, and I'm also affiliated with the American Chemical Society Division of Chemical Health and Safety, as well as the Committee on Chemical Safety and the Division of Chemical Education Safety Committee. So I have a good idea what's going on nationally in chemical education. Today, I'd like to talk to you about hazard analysis in academic research laboratories. So in the past, say 10 to 12 years, there's been quite a shift in how we approach chemical safety ideally and how we approach teaching chemical safety. And that's primarily happened in the last 5 years. In 2018, the American Chemical Society added safety to its core values to support our endeavors. And you can see here that it's coupled with professionalism and ethics. They're all very closely related, and the American Chemical Society has recognized that we need to teach these ideals to students and future chemists. So, what we want to do is we want to move laboratory safety into the 21st century and get away from 20th century ideas about chemical safety. In the 20th century, we basically developed a set of rules, and that was based on we identified some hazards for chemicals or processes, and we used a hierarchy of controls, and we prepared some rules. In the hierarchy of controls, there is an order to effectiveness, and the higher orders are more effective in eliminating risk. Rules live in administrative controls, and so you can see they're pretty low on the hierarchy as a way to control risk. As such, many incidents occurred and continue to occur based on this philosophy. So what we're trying to do now is we're trying to develop a risk management safety system. And that is, we're going to educate future chemists, we're going to improve the culture of safety, and we're going to perform risk assessments to determine what our hazards are, and then we can put better controls in place up here in elimination, substitution, and engineering so that we mitigate risk better. And the way to remember this is recognize hazards, assess the risks, manage or minimize risk, plan for emergencies, and protect the environment. So RAMP, we call it RAMP. The IRAMP is added because to do this, you need information. And so we need to teach information skills. And so you're getting a lot of that in this course as well on where to find primary literature, good information, and authentic information. We also take lessons learned. We can still use what we've learned in the past to improve this management system. And ultimately, we'll have an improved culture of safety. So we're going to try this through education. So how does it look? Well, if we look at the old paradigm, that's in yellow, and the new paradigm in blue, 21st century, we look at the technical aspects of safety and how they're transferred. It was assumed, and still in many cases is assumed, that if I do enough laboratory work in my undergraduate chemistry degree, that I'm going to encounter all the procedural skills that I need to protect myself and learn those basic rules. However, we need to start including hazard identification skills and risk assessment skills into laboratory work at the undergraduate level to move the paradigm towards the new version. Culture was based on enforcement and compliance. You may or may not have ever heard of the safety police, but we want to get away from enforcement and compliance. We do still have to comply with regulations. You cannot break the law simply because you're in academia, but we want to teach people that empowerment of a student or yourself is in protecting yourself is the better way to communicate culture. That is, if I understand what the hazards are I'm working with, I can feel empowered and therefore then I can be a leader in my group and actually take ownership of my own safety and in transferring that safety to others around me. So, safety information, how does it transfer? In the old paradigm, it was based on training built on compliance with regulations. So, you needed something to know something about lasers. You went and you took a course on once a year on laser safety, and that was all you thought about it. But what we want to look at is integrating educational subjects along with your required training. Some instances you have to do training, you can't get away from it. But we want to put topics into the curriculum that also reinforce training, and it's not just a one and done thing. So we want education and training. And safety management in the 20th century was based on the training and the rules you made. In the 21st century, we're looking at building a social construct, and a social construct is where everybody utilizes the same ideals, and so it needs to be resilient. That is, we can apply it to different uh, situations. It's transferable. I can teach it to the next generation. It's sustainable. It is built on inclusion of all people in the laboratory building the system or the risk assessment, and therefore everybody has buy-in to it, and it's compatible with discovery research. That is, I can apply it to the next situation I'm in. If you have a rule and it doesn't fit the next situation, you may not know what to do. So let's watch a little video on what exactly we're talking about with risk assessment.
Remember when you first started doing research in the lab? Everything was so daunting. You had to think about every step and make sure you'd really thought it through. But now that you've done it 100 times, it's easy, right? It's like crossing the street. No problem. You could do it blindfolded. No. Even though it's the same street that's part of your daily routine, you always look both ways. Always. Your experiment, like the street, is in flux. Science that seems straightforward turns out to be fairly complex. Conditions change, and even routine experiments carry risks. By assessing these risks and preparing for foreseeable emergencies, you can make the lab safer. And doing a risk assessment makes you a better scientist. A hazard assessment will identify all the possible things that could go wrong. And a risk assessment is a priority list of these, which are the most likely to present a risk. You've made a habit of looking both ways each time you cross the street. Make a habit of recognizing, assessing, and managing hazards, and preparing for emergencies. These steps are the foundations of a good risk assessment and the foundations of good science. I know what you're thinking. A risk assessment? There are always reasons why we become complacent. But I've only changed one thing. It's just another solvent, right? But I was only using a few drops of bromine. I've done this loads of times. I'm just scaling it up. I couldn't use the blast shield. Someone else was using it. But nothing has changed. But if I had done a risk assessment, I wouldn't have had time to set up the experiment. Don't worry, my colleague did a risk assessment, and I'm sure it was very thorough. Because both good science and lab safety require planning, preparation, and constant attention to changing conditions. Because you'd never say, I don't need to look both ways today. I did that yesterday.
The next section, we'll look at some definitions and how we can determine hazards and risks in the laboratory.